Hi everyone, thanks for having me today. So my name is Jean-Philippe Caissy. I'm a software developer at Shopify in Montreal, and my talk is going to be from idea to production in 20 minutes, engineering at scale. Just before we begin, for those of you who don't know what Shopify is, we are a e-commerce platform that allows you to create online store and sell products on the internet. One of the reasons I'm giving this talk is I wanted to highlight the different challenges that we had at Shopify that we face with the quick growth that we had in the recent years. At the end of last year, 2005, we had over 240,000 merchants using our platform. That was 11 months ago. Even today, we have over 325,000 merchants. That increase also came with an increase in the headcount that we have. So once again, we were almost over 100 employees last year. And as of today, we are well over 1,500 employees. Even though we're a big team, one other thing that we still want to continue doing is we want to ship things fast. However, one of the problems that we do face is that's not something that happens overnight. There's work to be done on it, and there's engineering effort that needs to happen. And that's what I'm going to try to talk about today. It really boils down to those two questions. Is your code base, is your project getting better by the day? Are you putting effort to do it? And also, how fast can someone new, a new hire, a new contractor, is able to get his environment set up and start shipping? Is it pleasant to do so? Being pleasant is something that wasn't really happening for us a few years ago. In the beginning, what we had is we only had a README file. You know what it is. There's instructions. There's bash scripts that you need to run. It worked well, but that just doesn't scale. One of the first solutions that we tried was using a configuration management solution. That didn't last at all. Also, the first tangible working solution we had was using Vagrant with cookbooks that we had on GitHub. So anyone could just clone the repo, get a development environment working on a VM. One of the next steps that we took is we now use a hypervisor. An OS X hypervisor that is lightweight, and with that we have bare-bone Linux images that the dev can use to set up. So having a good dev environment is there's those 5 criteria that you need to have. One of them, like I mentioned, is it needs to be really quick, it needs to be easy, and it shouldn't be painful at all to set up. It needs to be stable. You don't want your VM to crash. You don't want to have to restart your laptop every few hours, every few days. It needs to be easy to upgrade. So let's say you go on vacation, you come back 2 or 3 weeks after. It should be easy to stay on top if anything new came on your environment. It should be reproducible. You should be able to use it on different projects. And of course, it needs to mimic the production environment as close as possible. One of the tools that we use, that we've built internally, is basically a VM management platform. The only thing it does is it's going to download the OS images that we have, which are prepared to have all the services running. So each project basically is going to have its own VM, and it's going to have all the different services that are tied together. So MySQL, Redis, Memcache, Elasticsearch. Once we have those VMs set up, you need to be able to interact with it. We use a tool, so we've built some CLI tools called Dev, and it allows you to quickly set up your environment, which is configured with a YAML file, basically. So that YAML file will define all the different services that you need. So it's going to be your MySQL, your Elasticsearch, your Redis instances. It's going to define a host name that is going to be able, so that you can access it locally. Of course, define CPU, RAM resources. And you can also have some custom tasks to help a developer. So for instance, for a Go project, if someone wants to set up the Go project, you want to make sure that he has the Go root and Go path environment variable set up. Once you have it, it needs to be really quick to set up. So in our case, in just a few seconds, the tool is going to be able to provision your environment. You're going to have all the services running that are tied together, and it's easy to use. That configuration file is going to be committed to a project repo. It's a template base, so you can have it for Python applications, for Golang, for Ruby. We also have some that are used by our iOS and Android projects. One of the key features also that we have is it's also going to define the project's hostname, so that if you have different projects running on your laptop, on your dev environment, it's easy to access those. One of the easy ways that we do is we basically just have a domain name that is a wildcard that resolves to the VM's internal IP. And by having that, we've also provisioned a wildcard SSL certificate. And this is quite important because, as I said earlier, you really want to reproduce as most as possible your production environment. So if in your code you want to make sure that the request is coming from HTTPS, you want to make sure that it's happening also in dev. Once you have your development environment set up, it's basically just following your normal workflow. The one that we use, it's really basic. So we're just going to be using future branches. We heavily rely on all the different GitHub's tooling in place. So it's going to be so you're going to just create a pull request, have some code review happening. But even for the code review, it's quite important to have a process in place so that you just don't open up the PR, look through it in 5 seconds, and approve it. That doesn't work. It's really important for you to understand the full extent of the change. We want discussion happening also on the pull request that is not necessarily tied to the implementation, but you want to be able to discuss the approach that you use to build your solution. It's of course important that the test coverage is in place. You want to have a code consistency, and one of the most important features is basically you're learning from others, especially when you have new hires. It's really hard for them maybe to get on par, and if you want that to happen quickly, you need to dive them in directly in the project. Even if you have a code review, one of the other things that we really ask our devs to do is to have more than a code review. So we call it top hatting. So top hatting is basically just more than code review. When you top hat a code, it just assures you that you've actually checked out the branch, that you've run the code, that you've executed it, and that you've navigated and clicked through the different changes that happens. And by doing that, you ensure also that there's no bugs that is going to be introduced. If it's more front-end code, you're going to maybe want to test it on different devices to make sure that it works on Android, on iPhone, etc. It really helps avoid bugs, and it's quicker to diagnose when it happens. So once you have everything set up, you have your code and you're ready to merge. Of course, it needs to go through your CI. Once again, having a CI is not just having a test being run. There's really those 4 criteria that are really important to have also. You really want your CI to be consistent. You don't want to have tests that are failing randomly for no reason where you have to rerun. It needs to be fast. You don't want your test suite to take an hour or 2 hours. It's going to be wasting resources and it's going to frustrate developers. It really needs to be simple. And simple is, in our case, it needs to integrate with the different toolings that you have. So for us, it means that on your GitHub page, on your PR page, you're going to see quickly if there's anything that's bad. I talked about being fast. So here, this test took 27 minutes. That's really not good. Lots of engineering effort has been put in the past months to be able to have our entire test suite for our project to be under 10 minutes. And this really improved our different workflow. When I talked about consistency, if there's any failures that happen, so when you merge to master and you run your CI, if there's a test that fails, you want to make sure that you log this issue so that the team that is responsible for the feature will actually fix this. And by being scalable, in our case, we use BuildKite, and with the power of EC2, it allows us to scale horizontally really quickly. And the way it works is really easy. You just receive webhooks from GitHub for every branches that is created, and the CI is going to be run. Once you have everything, of course, it's time to merge. Once you've merged to your code, in our case, we're going to use master as the head of the application. It's time to ship. It's time to deploy. Deploying at Shopify really evolved throughout the years also. It all began, in the beginning it was still a manual process. So of course you'd had to go to the ops channel and ask for a manual deploy. That works for a few employees, but as you grow, that doesn't work. You're gonna need something that is automated. We've tried using a tool from Rackspace, which had huge performance problems. So we've decided to build our own tooling, which has been open source also last year, I think. So that tooling is called Shipit. So Shipit is basically our application that handles all the deployment. We have over 200 projects that are using it internally. And it allows you to deploy with the simple click of a button. And it also deploys itself. As I said, deployment is something that we do 100 times a day daily. So it's really important that it's quick, that it's simple to use. For a new project, it needs to be easy to integrate also. In our case, what we've did is we've reused the configuration model that is really similar to Traverse CI. So we're going to have a local configuration file that is on the project that will specify the different tunings required and different steps to deploy. Shipit also has integrated deployment to publish Python X, for instance. It can push to Heroku. And we also use it to deploy on our own data center. We also use it as an audit rail. So Shipit will keep the logs and all the metadata of the deployments that happen if it failed for whatever reason, and then you can go see you can go back to see the logs. We've made really a nice performance gains by adopting a really clever feature. So basically, instead of having a local copy of your repo and constantly polling to get updates from master or from any branch, we just use GitHub's master branch as the source of truth. That means that we don't have to keep a local copy, and we just use GitHub's webhooks. So every time that there's a new push to a master or to a new branch, Shipit is going to get it, and Shipit is going to have it. There's also very important to be synchronized. So when there's a problem, you want every developer is able to put a lock on the deployment so that no one ships code during an incident or during a system maintenance, for instance. One thing that's really cool is we even had a child deploy using the tool once. But this is all manual steps. Like clicking the button is still manual. So the next logical step that we had to take is remove that last manual step. Recently, I think a few months ago, so we decided to begin automatic deploying Shopify. So we have invested a lot of effort, as I said earlier, to have CI being under 10 minutes by having proper test coverage. But even having like this end-to-end process taking 20 minutes was too much for us. So we decided to remove the last manual step. Before we enabled the automatic deployment, what happened usually is during the morning or during the afternoon, there would be a backlog of commits that are not undeployed that would get all deployed at the same time. So having 20, 30 commits being deployed at a time can be dangerous at some point. And it happened also that we had unshipped changes that would not be deployed. So this is a problem if on a Friday you merge, you don't deploy, and then there's an emergency situation that happens on Saturday, for instance, and then you need to deploy, but there's like changes that hasn't been deployed. So as I said, even though it wasn't ideal, the manual process allowed us to ship maybe 30 to 40 times a day. Once we enabled the automatic deployment, it really reinforced 3 important cultural standards that we had at Shopify. The first one is it's a high expectations of the tooling that you use. You want them to work. It also increased the trust that we have with our tooling. So if it's deploying, you want it to work. And one of the last one is it really removed the fear that people had of deploying to hundreds of application servers. After only a month of enabling the automatic deployment, we've noticed some tangible results. One of them, of course, is we're shipping faster. At some point, as you see, we've shipped, there's a day where we made 180 different deploys. Second is, instead of having big batches of deployments, we're shipping more smaller pieces, with an average deploy now maybe being between 2 to 3 commits. Going further in the deployment pipeline, we still think that our deploy pipeline is not fast enough. We're not able to deploy each commits individually. We still need to batch them together. As I said, we need to have more stable tests, because when there's a test that fails randomly, it uses machine resources because you need to rerun them. It frustrates the devs that see a test failing that doesn't even happen on his local machine. We want also to be able to have an automatic spot check happening during deployment. So if you start deploying and then there's some performance or functional regression happening, there should be an intelligent system that is able to roll back to the previously known version. We also want to be able to have a more we also want to be able to roll out only to a subset of the production app servers. So let's say you want to deploy something to maybe 1% of the app server to make sure that nothing crashes. It's really fun. I mean, we use ship it to deploy, but to deploy an application. But we also use it for various different tasks. We heavily use Datadog at Shopify. It's where we have all our dashboards and we monitor the application. But having like hundreds of different dashboards and editing it was sometimes a pain. So what we decided to do is we use the Datadog API. We've pulled all the dashboards and we've put it on a version control. And we use ship it to deploy those dashboards. We also use the same thing for our DNS records. So all our DNS zones are simple YAML file, and we're going to be using ship it to change any DNS that needs to happen. One of the last pain that we had for a dev is the handling of secrets, handling credential informations. Of course, you don't want to have them on your version control. What we had previously is we just had them stored in an encrypted data bag that was being, and then Chef would use it to deploy on the app server. You'd always need to ping ops if you wanted to add something or change something. One of the tooling that we've built and we've open source is called eJSON, which is basically just a public key. It uses public key infrastructure to be able to put credentials inside your app. So you're just going to be have your credentials on a file. You're going to use eJSON to encrypt them, and then you're going to push it to your repo. The private key are going to be living on the production servers, so every devs now can change any credentials, and they don't need to ping anyone. With all that in place, there's one last bit that is really important, and it's communication. It's synchronization between the various teams that you have. There's various tools that can be used. Could use IRC, could use Flowdoc. We've invested in Slack, and one other thing that we did is we've put all our different integration, the toolings integrated inside our inside Slack. So in our case, our deployment platform, Shipit, will post messages on Slack telling when a commit is being deployed. We can also use it for exception handling, so it's going to report all the exceptions directly in Slack. We also use it as a chatbot. So instead of asking someone to add a user to GitHub, we're going to use that chatbot to add someone to GitHub. We also use it, for instance, to provision new Heroku apps or list Kafka clusters. So that was basically my talk. I hope you appreciate it. With all that in place, if you have any questions, feel free.
All right, I'll run the mic around for questions. Questions? Yes.
I was wondering if you could just talk about how you managed to get your test suite to be so efficient. What techniques you used?
So one of the simple way to do it is just paralleling your tests. So I think I had in one of my slides for our master branch, for instance, we had over, I think, 80 machines that runs our test. Yeah, that's what we have here. So there's 95 agents that runs the test. So that's one of the easiest thing. One of the way we do also is, so every instances of the CI is going to be using a Docker image, and that Docker image is going to be reused across all the tests also. So it's easier to launch a test.
Shopify has a lot of employees, and I can understand why you did this. But when do you think, like a smaller company or a smaller dev team, when do you think that they should invest in these kind of tools? Like, I think like CI and kind of code review kind of just comes with it. You kind of always do it, but these other tools, they take a lot of engineering effort, right? So when do you draw that line in the sand and kind of decide when it's needed?
I think it's it all boils down to like when does it suck? At what point the investment that you're going to take to solve those issues, there's going to be a payback on it. So, but it's also like changing the mentality of your of a company. Like since I've been working at Shopify, even my own personal projects, I tend to have a automatic deployment happening. Like I don't want to do it myself anymore. It's more of a mentality that you want to try to impose to the people.
How do you guys make the decision between rolling your own tools or using some open source tools? Like, I don't know if Travis is open source, but it's a big one. And are you using Ansible for deploying the stuff? Like, seems like you wrote a lot of your own tools.
That's a good question. I think so the way it happens is we're gonna try something that exists, and if we see that it doesn't fit our specific needs, we're gonna consider building something. But because of course, if you build something, then you need to maintain it. You need to make sure there's a team that knows what the project is. That if there's a problem, they're gonna fix bugs that's happening. So I think it's mostly around whether choosings that exist works for us.
When a developer introduces a change that requires configuration management, how does Shipit handle that?
So there's different ways. As I say, so we heavily use Chef for configuration management. So even the cookbooks are inside GitHub. So you could change them, and you're gonna deploy the changes using Shipit itself. And you're gonna want to do it before you have any code that needs to go live.
Any more questions? Oh, yeah, follow up.
You talked about the development VM that you give to all your new hires. How do you choose what goes into that development VM?
Yeah, that's something I might have not talked enough. Basically, the VM doesn't really have anything, we try to have the strict minimum. Like even when you work, you're not going to work inside a VM. The code lives outside, and the VM is just there to integrate the different services that you have, so that you don't have to configure MySQL yourself, for instance. So the code actually lives outside, and you just run it, and then Nginx inside the VM is going to be connected to is going to proxy back to your app locally.
So I'll inject my question as well. So we kind of already touched on this, but how much is there sort of a team of people at Shopify that enable this behavior, or is it really just all the developers sort of scratch their own itch and collectively make things better?
So we do have a team that is responsible for all those various tunings. I'm not sure how many people are on it, but it's also something that, like I said, doesn't happen overnight. Since the beginning, there was always this culture of building for the long term, which is also why the tools that we had, we've quickly built them to solve the issues that we had.
All right, any more questions? And of course, you can always, I imagine you can stay around in the hallway a bit to have further discussions with other people. All right.
Thank you.